All right, so this is lesson 29. This is the only lesson that we're going to do that involves imaginary numbers, just so you guys know. There are really no imaginary numbers in 1050. The only time you're ever going to see an imaginary number is if you use the quadratic formula and you end up with a negative inside of a root. That's the only thing we do with imaginaries. So this lesson is more imaginaries than what you're going to have to do in 1050. Okay? All right, here we go. So the definition of the square root of a -1 is an I. Okay? So if I had like this, you guys, the square root of -25. Okay? The negative inside the even root gives you an I, and the square root of 25 is 5. Okay? So the square root of a -25 is a 5i. If you see an I to the first in your problem, I want you to just leave it an I to the first. If you have an I to the second, guys, that's an I times an I. And each of those I's is the square root of a -1. So that's the square root of a -1 times the square root of a -1. What is that equal to, you guys? -1. Yeah, like the square root of 4 times the square root of 4 is 4. The square root of 5 times the square root of 5 is 5. Square root of a -1 times the square root of -1 is -1. So when you see an I squared, just replace it with a -1. Okay? All right. Everybody look at question number 2. The square root of a -1 is an I. So just write down an I. Make the dot like really big and really apparent, okay? And then go +3, distribute the negative, and you get -5 plus 2i, okay? Off to the side, I want you to write a plus bi. That's how they're going to want you to write all these answers. And I know it's strange, but that's what you have to do. So you have to put the number first and then the I second. So 3 minus 5 is a -2. And then I plus 2i gives me 3i. And that's my answer. That's it. Okay? Question 3. You're just multiplying. So guys, look. Positive times a negative is a negative. 3 times 1 is 3. I times I is I to the second, okay? You guys, you can't have an I to the second in your final answer. So I'm going to take the I to the second, I'm going to replace it with a what? -1. Is this right, you guys? Look, -3 minus 1 is -4. Is that right? What's wrong? They're supposed to be multiplied. So this is actually -3 times -1, which gives you a +3, and that's your answer. Okay, who says this is easy? Raise your hand, let me see. Okay, great. Look at question B. Everybody stop for just a second. Up above it, will you write this down? 8, oh, that's pretty fat. Write down 8x, parenthesis, 4 minus 3x. When you do question B, those I's work just like X's. So could you do this problem right here, guys, if they were X's? Of course you would. You would just distribute, right? That's exactly what we're going to do. So it's really so easy. So 8 times 4 is 32, and you have an I. And then 8i times a -3i. Positive times a negative is a negative. 8 times 3 is 24. I times I is I to the second. Are we done? What do we have to do? I to the second's a -1, right? Everybody look, 32i minus 24 minus 1. Very common. Is that right? No. Look what I've done. I had 2 terms here, and then suddenly my 2 terms turned into 3 terms. I can't do that. So you guys already answered the question. The -24 is supposed to be multiplied by a -1. But you know what, you guys? You don't even have to write that down, because you can just write down 32i. And then what's this going to be? It's going to change the sign, so it's a +24. Now, that is not in the form of a plus bi. So I have to write it as 24 plus 32i, and that's it. On the quiz, it's going to tell you guys, write it as a plus bi. And for every single question that you do, and there's a good number of them, if you don't have it in that form, you're going to lose a point every time. So just be really careful on this, okay? Okay, question C, right up above that, everybody write 3 minus x times 5 plus 4x. That's what I want you to see when you look at it. That's exactly the same. Unless you have an I squared, you make it a negative 1. Okay? You guys, am I adding those things together or am I multiplying? Talk to me. Multiplying. So 3 times 5 is 15. 3 times 4i is 12i. A negative I times 5 is a negative 5i. A negative times a positive is a negative. Watch this, guys. 4 times 1 is 4. And then I've got I squared. But guess what? I'm not even going to write down that I squared. I'm just going to take my 4 and do what to it, everybody? Change the sign. Yeah, so it's going to become a positive. And then remember, let's write it as a plus bi. So 15 plus 4 is 19. 12i minus 5i is a positive 7i. That's my answer, and I'm done. Okay? Raise your hand if you're totally good. Raise your hand. Do me a big raise. Okay, yay. Okay, here is question D. Okay? Up above it, everybody write this down, okay? Parenthesis, 6 minus x plus parenthesis, negative 2 plus 5x. You know what people start doing? They start multiplying. Look right here. 6 times negative 2 is a negative 12. 6 times 5i is 30i, etc., etc. I'm not multiplying. Someone tell me how I know I'm not multiplying. Got the big plus in the center, right? So look at the first parentheses. There's nothing in front to distribute. So guess what? They weren't even necessary. I didn't even have to have them. Look at the second set of parentheses. Same thing. There was just a plus in front of it. So I'm just going to write minus 2 plus 5i. So none of those parentheses were even necessary. And then I'm just going to write it as a plus bi. 6 minus 2 is a 4. A negative 1i and a positive 5i is a positive 4i. That's my answer. That's it. Okay, question E. Same thing. The first set of parentheses, not necessary. So everybody write down negative 4 minus 2i. Were the second set of parentheses necessary, everybody? Yes, because we're distributing the negative, right? So a negative times 2 is a negative 2. A negative times a negative is a positive 8i. And then write the constant first. So a negative 2 and a negative 4 is a negative 6. A negative 2i and a positive 8i is a positive 6i. That's my answer, and I'm done. Yes, sir?
So if we had a question with x's and i's, we write it like number plus quotient x and then constant and then the number of I.
I don't know. Do you mean within the same term, or do you mean separate terms? So you could have 4ix plus 3x plus I. I don't know if you mean i's and x in the same term, or if you mean i's and x's, you know. But
Ask about the second one for both to be applicable.
okay, so the answer is it doesn't matter. But I'll tell you, you cannot add this to this because this guy has an x and this guy has an x and an I.
Well, I'm asking about the order you write it in.
It doesn't matter. Yeah, good. Good job, bud. Okay. Next one. Sorry. If I zoom in too close, it like pushes me to a totally different spot. Sorry. Tell me what page we're on, would you? 129. Okay, I'm almost there. Okay, here we go. All right, great. Okay, rationalize the denominator. Okay, question 4. So what this means is, rationalizing the denominator means there's something on the bottom, the denominator, that's not supposed to be there. Okay, so everybody look at question A. What's there that should not be there? The I. Is the 3 okay? The 3 is fine. So it's just the I. So guys, you don't multiply top and bottom by 3i. It's just I. Because if you do 3i, the numbers are going to be bigger and then you're going to have to reduce and that's a pain. Okay? So on the top, 5 times I is 5i. On the bottom, you guys, I have 3. What else do I have besides a 3? An I squared. I squared's a -1. Now, everybody listen to this. I could put my negative here. I could put it here, or I could put it here. I would obviously not put it in all 3 of those places, just one. Where's the best place to put it? At the very top. Yep. So let's write it like that. If you put it somewhere else, you would still get it right. It's just not as safe. Okay. Okay, question B is different, you guys, because it's a binomial, 2 terms. So I multiply top and bottom by, does anybody remember? It's the conjugate, yes. So that means you take the 7 and it's plus 2i. And you have to multiply the top by exactly the same thing. Okay, on the top, everybody write the word FOIL. On the bottom, everybody write the word FOIL. So let's FOIL the top. 7 times 4 is 28. 4 times 2i is 8i. 7 times I is 7i. And then I times 2i is 2i squared. See how I just wrote that I squared? I would never even write it. I would just go 2i squared, and then I'd say, oh yeah, that means just come over here and change that plus 2 to really a -2. Okay? Everybody freeze right here, and I want you to talk to me. This is kind of a good little review for your final. Do I really have to FOIL the bottom? Do I have to do that? Why not? Someone said cancel. What cancels? The middle 2, which are what letters in FOIL? The O and the I. So the O and the I are going to cancel out because they're conjugates. I'm going to get 14i and -14i, and those go away. So all I really have to do is first and last. Okay? So 7 times 7 is 49. A -2i times a +2i is a -4i squared. I'm not even going to write the I squared. What am I going to do? Make it a +4. Very good. Okay? 28 minus 2 is 26. 7i plus 8i is 15i. 49 plus 4 is 53. Now, if they asked you to write it in the form of a plus bi, okay, look what you have to do. It's easy. You go 26 plus 15i, but there was a 53 on the bottom. You just write the 53 underneath those 2 terms separately. So the A would be 26 over 53, the B is 15 over 53, and then you've got your I. So that's your answer. Okay? Who says this lesson's easy? Let me see. Raise your hand. Okay, good. You okay? Feel good about it? All right. Question. This little example doesn't have a number. Okay? The square root of 4 times the square root of 9. That is the square root of 4 times 9, which is 36, and the square root of 36 is 6. Guys, everybody listen right here for a second, please. Someone in one of my classes, I don't know, I think it was a 1010 class, they said, right, but it's a square root, so shouldn't I have a plus or minus in front of it, okay? The only time you do plus or minus is when you do the square root. So if the square root is there to begin with, and there's no plus or minus in front of it, then you don't add it. When you do the plus or minus, as if you have like this, guys, look, x squared equals 36. Then you're doing the square root, so that would be x equals plus or minus 6. But that is not the case over here. Who says I understand the difference? Let me see. Okay, great. Look at this one. You do not do this. Square root of a -4 times the square root of -9. -4 times -9 is 36. Square root of 36 is 6. That's wrong. Can anybody tell me why? Because you've got i's is exactly right. Okay, so I want you to write down i's first. So the very first thing I want you to do is to take out those i's. Okay, so this negative comes out as an I. So you have I times the square root of 4. This negative comes out as an I. So you have I times the square root of 9. Okay, the square root of 4 is a 2. So you have a 2i. The square root of 9 is a 3. So you have a 3i. Now I'm multiplying those. So 3 times 2 is 6. I times I is I to the second. What's I to the second? -1. Yep. So your answer is -6, and you're done. Okay? All right, here's question 5A. Everybody in the room, tell me what to do first, very first. I's, right? So you have I times the square root of 2 multiplied by I times the square root of 8. So on the outside, you have I times I, which is I squared. On the inside, 8 times 2 is 16. Now the I squared is multiplied by the square root of 16, okay? The square root of 16 is a 4. What's I to the second? -1. So they're multiplied by each other, so that's just going to make that a -4, and you're done. Okay, question B, I's. So I'm going to write this as I times the square root of 5 over the square root of 16. What's the square root of 16? 4. I'm done. Literally, that's all I have to do. Okay, next one. Negative comes out as an I. I've got a square root of 5. Now, the square root of 27. 27 is 3 times 9, and 9 is 3 times 3. So these two 3's are going to come out as a single 3, and inside, I still have a 3. Okay? Am I done, you guys? Tell me. I'm not done. What's wrong? Can't have a square root of 3 on the bottom, right? So let's multiply top and bottom by the square root of 3. So on the top, you have I, square root of 5 times 3 is 15. On the bottom, on the outside, you have a 3. But then you have the square root of 3 times the square root of 3, which is, tell me everybody, a 3. Yep. So then you have I, square root of 15, all over 9. Can my 9 and 15 reduce? Talk to me about that. No, why not? One's in, one's out. So no, you cannot do that. That's my answer, and I'm done. No plus or minus. The plus or minus was not there to begin with, so don't add it. Okay? Okay, question D. What would you do first? Okay, take out the I, and I've got write it twice. And guess what? It doesn't matter. It doesn't matter. You can do either one of those. My opinion is I would take out the I first, okay? So I would love you to write as -1 plus I square root of 3 squared. Now write it twice. So let's write it as -1 plus I square root of 3 times -1 plus I square root of 3. Now I'm going to multiply those together. So -1 times -1 is 1. And -1 times I squared root of 3 is -I squared root of 3. I squared root of 3 times a -1 is a -1I square root of 3. Now I'm going to do last. I squared root of 3 times I squared root of 3. Positive times a positive is a positive. I times I is I squared. Tell me what to do. Change a plus to a minus. Yep, don't even write the I squared. It's not necessary. And then the square root of 3 times the square root of 3 is, talk to me everybody, 3 is correct. Good. Let's write it in the form of A plus BI. So 1 subtract 3 is a -2. And -1I squared root of 3 and -1I squared root of 3 is a -2I square root of 3. There's your answer, and we're done. Okay? Okay, that was D. Here's E. Everybody in the room, tell me what to do first. I's first, right? So you have I times the square root of 12 minus I times the square root of 27. You guys remember when you add or subtract radicals, you can't add them unless they're the same, and they're not the same. So what do I do, everybody? What do I do? Am I done? Harrison, what do I do, buddy?
Actually, I have a question.
Okay, go ahead.
Sorry.
Yeah.
Didn't you just distribute that negative, that minus in between?
No, you can't, because this negative is an I, so you can't do that. Okay? Yes. Let me say something really fast. Harrison, you can't pull anything into a root, ever. And the only time you can pull something out is if you have two of them. Okay, yes. You're good? What do I do? Does anybody know what to do? Break it down. Good. So let's write down the 12, right? So 12 is 2 times 6. 6 is 2 times 3. These two 2's come out as a single 2. So I have 2i square root of 3. Then in 27 is 3 times 9. 9 is 3 times 3. These two 3's come out as a single. So it's minus 3i square root of 3. Now, in order to add these, you have to have the I and the square root of 3. I and the square root of 3. So I'm good to go. I can add them. It's just the number in the front that is the only thing that ever changes. So 2 minus 3 is a negative 1, and I'm done. By the way, if they told us to write this as a plus bi, how would you do that? Say it again. No, because they're multiplied right now. No, because it's still, this whole thing is still just that. So the b, just so you know, the b is a negative times the square root of 3. Because you've got a negative and a square root of 3 multiplied by the I. What about the a? Come on, guys. There is no a, so how do I write that? Yes, it is 0 minus I square root of 3. Okay, so just be careful with that. If there's nothing added to the I, then you've got to make it a 0 added or subtracted to the I. Okay, all right, question E. Okay, we're almost done. Yeah, it goes fast. Okay, here we go. Everybody write this down for me, okay? B squared minus 4ac. Okay, if I was doing the quadratic formula, and when I did that b squared minus 4ac, I got a 0. Okay, I want you to just imagine what that would be. Okay, let's just add some things around it. So let's go negative 1 plus or minus the square root of 0 all over 4. I'm just making those numbers up. It's the square root of 0 that I'm caring about. Okay, so if b squared minus 4ac is a 0, then look what happens. The square root of 0 is a 0. Adding and subtracting 0 doesn't change anything. So literally this whole thing would just go away. So then what you'd have is a negative 1 over 4. Negative 1 over 4 is a real solution. It's not imaginary. And how many do you have? 1. So if you get a 0 right here, if it's equal to 0, you have one real solution. Okay? Okay, let's say b squared minus 4ac was the square root of 3. So let's say you had negative 1 plus or minus the square root of 3 over 2. Are those answers right there? There are two of them. One's a plus square root of 3, one's the minus. Are they real or are they imaginary? Which one are they? Real. So we have two solutions. One of them is this, negative 1 plus the square root of 3 over 2. The other one's negative 1 minus the square root of 3 over 2. So I have two solutions, and they're real. So if it's greater than 0, you have two real solutions. Okay? Let's do this, guys. Everybody go plus or minus the square root of a negative 5. What if your b squared was a negative 5? Okay, let's fill in some numbers in front, like a negative 1 and a 7 or something like that. How many answers are there right there? Everybody in the room tell me. How many do I have? 2, because the plus or minus, right? Are they real or are they imaginary? They're imaginary. If they're imaginary, guys, they're called complex. So you'd have 2 complex, okay? Okay, here we go with question 6. Evaluate the discriminant. So everybody just go b squared minus 4ac. That's a negative 2 squared. Everybody in the room tell me what a negative 2 squared is. That's a 4. Yes, it's always positive. Minus 4 times a, which is 5, times c, which is a 1. Grab your calculator. Okay, right now, everybody grab your calculator and go 4 minus 4, parenthesis 5, close it off. You don't have to do if the 1 if you don't want to. Hit enter, and you get negative 16. Now, that negative 16 would be inside of a root. So are they going to be real or are they going to be complex? complex. And how many are we going to have? You're going to have 2 of them. Why 2 of them? Because you've got that plus or minus in front, right? So the answer is 2 complex, and that's your answer. Okay, let's do question B. B squared, that's 1 squared, which is 1, minus 4 times A, which is 6, times C, which is a negative 2. You guys, I have 1050. Are they 1050 students that did this? Yes. I have 1050 students that are not trusting me, and they're not putting that in their calculator, and then they're getting the wrong number, okay? So just know that that's a thing that people struggle with. So just go 1 minus 4, parentheses 6, close it, new parenthesis, negative 2, close it, enter, and I get 49. Real or complex? Tell me. Real. And how many am I going to have? How many real? 2. Why 2? The plus or minus. Yeah, that's it. That's all you have to do. Okay, question C. B squared minus 4AC. 5 squared is 25 minus 4 times A, which is 3, times C, which is 10. Everybody go 25 minus 4, parenthesis, 3, close it, new parenthesis, 10, close it, enter, and I get negative 95. Real or complex? Talk to me, everybody. Complex. How many complex? 2. Why 2 again? Plus or minus. Same answer. So it's plus or minus the square root of 95. Okay? Question D. B squared, that's 2 squared is 4, minus 4 times 1 times 1. Do you really have to write times 1 times 1? No. That's just 4 minus 4. So it's a 0. So the plus or minus and the square root of 0 is all going to just cancel out. So the only thing you're going to have is a negative b over 2a. How many answers? 1. Real or complex? Real. 1 real. You guys are awesome. Everybody's answering me. I feel like you're good. Who says I'm good? I feel good about this lesson. Okay, yay. Yes. No. Always going to be more than 1. Because you're going to have that plus or minus, and then the square root would be a negative, so plus or minus the I always going to be 2. Good question. Okay, question 7, just so you know, I think this is going to be on the final. And I don't feel like I've taught this well. Okay, so here's our chance right here. What are the zeros? What are the solutions? Okay, so everybody go x to the second plus 5x plus 7 equals 0. Now, I can see that that does not factor. Could I complete the square? Yes. Do you want to complete the square? No way, because that 5's terrible. So what should we do? Quadratic formula. Everybody go x equals 5 squared is, or pardon me, negative b means negative 5, plus or minus the square root of 5 squared is 25, minus 4 times 1, I'm not even going to write it, times 7, all over 2 times 1 is a 2. Okay, so now I have x equals negative 5 plus or minus the square root of, if you put that in your calculator, 25 minus 4 times 7 equals, you get negative 3 over 2. Okay, now, what do I have to do right now? It's very simple. What do I have to do? Say it again. Make an I. Yes. So you have x equals negative 5 plus or minus I square root of 3 all over 2. Those are the solutions. Okay? I think we've done well with that. Here's what we have not done well with. How many x-intercepts does it have? You can't see imaginary intercepts. You cannot see them. It's not really an x-intercept. So how many do we have, guys? We have 0. Imaginary solutions are not x-intercepts. So we have 0 x-intercepts. Now I want everybody to freeze for a second. Draw an xy axis on your paper. What if I graphed this? Someone tell me what that would be. It's a parabola, Does it open up or does it open down? It opens up because the x to the second has a positive coefficient right there. How in the world can a parabola have no x-intercept? Someone tell me what it's going to look like. Shift it up, right? So it actually looks like this. Do you see how there are no x-intercepts? That's why they're imaginary, because the whole parabola is shifted up above the x-axis. Okay? Who says I understand that? Raise your hand, let me see. Okay, great. Okay, question 8, I want you to do this. 1, 2, 3, 4. I want you to list 4 methods of how you could solve a quadratic equation. What's a quadratic equation? X squared. Yep. Thank you, bud. X squared. I'm going to call on someone, and when I call on someone, I want you to tell me the one that you think is the easiest. There's no right or wrong answer. I have my own opinion. Which one's the easiest of the 4? Ryan, which one do you think is the easiest, buddy? I'd say for sure, factoring. Who agrees with that? Factoring. Okay, if you don't have factoring written down, then write it down. Okay? I want the second easiest method in your opinion. Abigail, what do you think is the second easiest, honey? That's what I'd say. Quadratic formula. Okay? Who says I agree? Anybody? Raise your hand. Okay. How about another method? Harrison, what's another method? Completing the square. Yep. One more that maybe some of you have a hard time finding out. What is it, bud? It is graphing. It is graphing. And I think, in my opinion, these are kind of tied for last place. Completing the square and graphing. That's in my book. Say it again. Well, I think completing the square can get really ugly really fast. But if it's a clean equation, I think it's actually pretty simple. And I think graphing could be pretty easy too, just depending on what the equation looks like. Okay? Okay, so that's it, you guys. We are done.